Good evening. Today's quote is the best preparation for tomorrow is doing your best today. The best preparation for tomorrow is doing your best today. Today's word is tenacious means not likely to give up or let something go. That is determined. Exercise 1.1, sum number 6. Find the value of. Now, what is I raised to 6? I square cube, but I square is minus 1. If index of minus 1 is odd, answer is minus 1. What is I raised to 7? I raised to 6 into I, but I raised to 6 is minus 1 into I is minus I. What is I raised to 11? I raised to 10 into I, laws of indices, but I raised to 10 is fifth power of I square. Minus 1 raised to 5 is minus 1 into I is minus I. So substitute the values. 3 plus 2 upon I as it is into minus 1 plus I, 1 minus I. Now from these two terms, I have taken minus 1 common. I'm not saying this is the only method. You may say, sir, we will open the bracket. Is that correct? Yes, you will get the same thing. Okay, but here I could see that this is square of 1 minus I. Now it is I square minus 1. 1 minus 1 cancel. So minus into minus 2i is plus 2i. Open the bracket to get 6i plus 4. Usually we write answer in which form? A plus ib. So 4 plus 6i is the answer. Sum number 7, evaluate the following. I raised to 35. Now, see, working rule is simple. If index is odd, write that with even index. Means what? I raised to 35 is I raised to 34 into I. Now, every even number is 2 into something. So I raised to 34 is I square raised to 17 into I as it is. I square is minus 1. If index of minus 1 is odd, result is minus 1. Minus 1 into I, minus I. Second, I raised to triple eight. You may ask, can we write this as I raised to 4 raised to triple two? Yes. And I raised to 4 is 1. Instead, I have written I square raised to triple four. I square is minus 1. So minus 1 raised to triple four. Minus 1 raised to an even number is, is nothing but 1. Okay. So this is 1. What about third? Third is nothing but I raised to 93, which is I raised to 92 into I. I raised to 92 is I square raised to 46. I square is minus 1. Raised to 46 is 1. 1 into I is I. Fourth one, I raised to 116 is I square raised to 58. Minus 1 raised to 58 is plus 1. I raised to 403. I raised to 402 into I. That is I square raised to 201 into I, that is minus 1 raised to 201, which is minus 1 into I, that is minus I raised to 58 is rather 1 upon I raised to 58. Now what is I raised to 58? I square raised to 29. I square is minus 1. Minus 1 raised to 29 is minus 1. So 1 upon minus 1, that is minus 1. Seventh, I raised to minus 888. You may say I square raised to minus 444. No, don't do that. 1 upon I raised to triple eight. Here you may say I raised to 4 raised to triple two. But I have written I square raised to triple four. But I square is minus 1. Minus 1 raised to even index is 1. So what is the answer for sum number 7? It is 1 only. Now go for sum number 8. I raised to 30 plus I raised to 40 plus I raised to 50 plus I raised to 60. I hope you will not say add indices. That is wrong because indices are added in case of multiplication. This is just addition. Each index you will notice that is an even number. So we can write as I square raised to something. Now it is I square minus 1. So minus 1 raised to 15 plus minus 1 raised to 20 minus 1 raised to 25 minus 1 raised to 30. So this is minus 1 plus 1 minus 1 plus 1. It is nothing but 0. So what is the answer? Answer is nothing but 0. Sum number 8 and 9 for homework. In the 8th sum, you are asked to show that it is a real number. On simplification, you get 0, which is real. Ninth, find the values of. Answer for the first part is 2i, and for the second, it is nothing but 0. We'll be doing sum number 10 in the class. I hope in your textbook, the sum is like this only. Solve I raised to 592 and so on. Let me write the sum. So I begin with let a plus ib be the given complex number. Just check this. Is it I raised to 592 plus I raised to 590 plus I raised to 588 plus I raised to 586 plus I raised to 584. This is numerator. What is denominator? I raised to 582 plus I raised to 580 plus I raised to 578 plus I raised to 576 plus I raised to 574. Now tell me what can be done here. I think can we take I raised to 584 common from numerator? Just see, I raised to 584. Yes, we can. So what remains in bracket is I raised to 8 plus I raised to 6 plus I raised to 4 plus I square plus 1. And from denominator, what can be taken common? I think I raised to 574. I raised to 574. So in bracket, we get the same. I raised to 8 plus I raised to 6 plus I raised to 4 plus I square plus 1. So this is I raised to 10, which is I square raised to 5 minus 1 raised to 5, which is nothing but minus 1. I think answer given in the textbook is wrong. Sum number 11, find the value of 1 plus I square plus I raised to 4 plus I raised to 6 up to I raised to 20. If you know geometric progression, answer can be obtained easily, but we haven't done geometric progression yet. So observe that first term is 1, second is I square, which is minus 1, third is I raised to 4, which is plus 1, fourth is I raised to 6, which is minus 1. So terms are alternately 1 and minus 1. So addition of first two is 0. Addition of next two, 0. That is why I have written addition of first 20 terms. 1 plus I square up to I raised to 18. uh, I should have I should have said first 10 terms, right? These are in all these are in all 11 terms, not 20. I'm sorry. So I should have written addition of first 10 terms is nothing but 0, right? So required sum is nothing but these are the first 10 terms, their addition is 0 plus I raised to 20, which is I square raised to 10, but I square is minus 1, raised to 10 is plus 1. One student is saying, sir, can I find, these are only 11 terms, so I will find each term and add them. Is that correct? Yes, for that method also you will get full marks. But final answer must be the same. Many students argue, sir, we have got different answer because we have used different method. This is baseless argument. Final answer will be the same irrespective of the method used. See, when a person checks the paper, he or she gets ideal answer sheet, which is called as memorandum. In that it is clearly mentioned that any correct method should be given full credit. But I will advise you to use the method which is given in the textbook only. I call it as Rajamanya method, accepted by all, right? Here, if you use different method, then I will see that whether that method is correct or not. It may not happen in board exam. So it is better that you follow the method which is given in the textbook. Do not use different method. Okay. So this is the answer. Now, as I said, sum number 12 is for homework. It is simple sum. Okay. So 11 homework. There is no question of giving the answer because you are asked to prove something. Means you have to prove the same thing. Then 13. In fact, this is, we have done 11. This is 12. I'm sorry. We have just finished 11. So this is 12 sum for homework. 13th is also for homework. Let me read the sum for you. Is 1 plus I raised to 14 plus I raised to 18 plus I raised to 22 a real number? Minus 2, which is real number. Okay. On simplification, you get minus 2. Just write down this. But do try some 12 and some 13 after the lecture. See, in board exam, I mean 12th standard HSC exam, almost all the sums are from textbook only. So you should be able to solve each and every sum from the textbook. Sum number 14. Evaluate I raised to 37 plus 1 upon I raised to 67. Okay. See, there are many ways. You may say we will find LCM. You may say we will simplify each term separately. Choice is yours. Okay. So I can say this is I raised to 36 into I plus 1 upon, what is I raised to 67? I raised to 66 into I. So I square raised to 18 into I plus 1 upon I raised to 2 raised to 33 into I minus 1 raised to 9 into I, okay, plus 1 upon minus 1 raised to 33 into I. See, this is in the denominator. You have to be careful. So this is minus 1 raised to 9 is minus 1. I will directly write minus I plus 1 upon. This is again minus I. Okay. So this is minus I plus 1 upon minus I, multiply numerator and denominator by I. See, if you're not getting this, please tell me. I'll again explain. So minus I plus I upon I square, which is minus 1. So this is what? 1 minute. Is this correct? I raised to 36. I'm sorry. I square is minus 1. Minus 1 raised to, I should have written 18, right? This is what? Yes, yes, yes. Somebody has already written this in chat box. So there is, this is plus I. Okay. So this is plus I. I'll explain once again to avoid confusion. Plus I. So final answer is 2I. Is it? Just check this. What is the answer for 14th sum? I raised to 37 is I raised to 36 into I. I raised to 36 is I square raised to 18. But I square is minus 1. Minus 1 raised to 18, 1. 1 into I. Yes, this is I. What is I raised to 67? I raised to 66, which is I square raised to 33 into I. But I square is minus 1. Minus 1 raised to 33 is minus 1. So finally, here we have I plus 1 upon minus I. Multiply numerator and denominator by what? I. So I will just remove this plus sign, because I mean plus I means I only. Okay. So this is I plus I upon minus I square. I square itself is minus 1. So minus minus plus. So I plus I, that is 2I is the answer. One student is saying I'm getting minus 2 upon I. Same thing. Minus 2 upon I is nothing but 2I. Why? Because multiply numerator and denominator by I. You get the same. This sum can be solved using another method. What is LCM? I raised to 67. So I raised to 37 into I raised to 67 is I raised to 104, which is I square raised to 52. I square is minus 1 raised to 52 is 1 plus 1 upon what is I raised to 67? I raised to 66 into I, but I raised to 66 is I square raised to 33 into I. I square is minus 1. Minus 1 raised to an odd number is minus 1. So minus I. Now to divide by minus I means to multiply numerator and denominator by conjugate of minus I, which is plus I. Now 1 plus 1, 2. So numerator is 2I. What about denominator? Minus I square. I square itself is minus 1. So minus I square is plus 1. So 2I is the final answer. See, method is different. Still, we are getting and we must get the same answer. Some number is 15. Prove that 1 plus I raised to 4 into 1 plus 1 upon I raised to 4 is 16. Now, what is 1 plus 1 upon I? LCM I. So I plus 1 raised to 4 upon I raised to 4. I have written this directly. Now, 1 plus I raised to 4 into I plus 1 means 1 plus I. Again 1 plus I raised to 4 can be written as 1 plus I square raised to 4. What is the advantage of writing this? See, 1 plus I square is 1 plus 2I plus I square. I square is minus 1. So 1 minus 1 get cancelled. So 2I raised to 4. 16I raised to 4. In fact, I should have kept I raised to 4 as it is, right? But here I replaced I raised to 4 by 1. So again I like to say this I raised to 4 is also 1. So final answer is 16 into 1, that is 16. You could have begun with LHS equal to, that is also correct. LHS equal to 16, then you have to say, oh, it is RHS. So LHS is same as RHS. Sum number 17. This is an important sum. Before that, sum number 16 is for homework. Find the value of. Answer is 0. Sum number 17, important sum. A is minus 1 plus root 3i upon 2 and B is minus 1 minus root 3i upon 2. Show that A square equal to B and B square equal to A. Now this is given. Number 1. A square. What is first plus second square? Square of the first plus 2 times the product, but one term is negative. So minus 2 root 3i plus square of the second 3i square upon 4. I square is minus 1. So 1 minus 2 root 3i minus 3 upon 4. So minus 2 root 3i upon 4. Divide numerator and denominator by 2. If you argue, sir, 2 to 4 and this 2 gets cancelled with this 2, that is absurd. You have to take 2 common from numerator and then cancel 2. So what is A square? Minus 1 minus root 3i upon 2. But this is B, reason from 1. So this is the first part. Okay. One student is saying, sir, we haven't finished writing. Okay, take your own time. Also, B square minus 1 minus root 3i upon 2 square. See, I have seen many students who say in square all the terms are negative. That is absurd, ridiculous. See, okay, I'll simplify this. If you think so, take minus sign common to get 1 plus root 3i, okay, upon 2, complete the bracket, square it. Now tell me, what is minus 1 square? It is plus 1, right? And what is 1 plus root 3i square? 1 plus twice root 3i. Something is, there is some problem with the pen. Okay. Yes, minus 1 square is plus 1. So 1 plus 2 root 3i plus 3i square upon 4. So 1 plus 2 root 3i minus 3. You have to write reason every time that I square is minus 1, right? So minus 2 plus 2 root 3i upon 4. Divide numerator and denominator by 2. So minus 1 plus root 3i upon 2. But note that this is nothing but a. Reason from 1. Therefore, a square equal to b and b square equal to a. Right now. Sum number 18. If x plus iy is cube of a plus ib, show that x upon a plus y upon b is 4 into in bracket a square minus b square. Now what is a plus b cube? A cube plus thrice a square b plus thrice ab square plus b cube. Here b means ib, right? Now I square is minus 1. So what is I cube? Minus I. So x plus iy becomes a cube plus 3a square bi minus 3ab square minus b cube I. That is x plus iy equal to real part is a cube minus 3ab square. And what is imaginary part? For that take I common. It is 3a square b minus b cube. Please do not write in this fashion. This stands for on equating real and imaginary parts separately. So x is this, take a common. Y is this, take b common. But what is asked? X upon a plus y upon b. So x upon a plus y upon b is a square minus 3b square plus 3a square minus b square, which is 4a square minus 4b square. That is x upon a plus y upon b equal to 4 into a square minus b square. Sum number 19. If a plus 3i upon 2 plus ib is 1 minus I, show that 5a minus 7b is 0. Just cross multiply, open the brackets, replace I square by minus 1. Right hand side is to be written as a plus ib, that is real part plus imaginary part I. Now this stands for unequating real and imaginary part separately. So a is b plus 2 and imaginary part 3 is b minus 2, that is b equal to 5. This gives a equal to 7. Now what is asked? We are asked to show that 5a minus 7b equal to 0. Substitute the values of a and b. You get 35 minus 35, which is nothing but 0. See, choice is yours. You may say, can we write LHS equal to and then equal to RHS? Yes, that is also correct. Okay. So that's it for today.